Hello everyone. With the Stanford Scholar Initiative and are presenting before you the paper Using Hierarchical Skills for Optimized Task Assignment in Knowledge-Intensive Crowdsourcing, authored by Panayotis Mavridis, David Gross Amla, and Zoltan Michaels. Crowdsourcing is the practice of engaging people from online communities to obtain needed services, ideas, or contents by using their contributions. With growing popularity, crowdsourcing tasks are becoming specialized and demand special skills. With the introduction of knowledge-intensive tasks, it becomes crucial to have a control over quality of results. For this, it is important to assign workers with tasks they are good at. There is a need for a task assignment algorithm that can give the best possible matching by maximizing the overlap between the skills of the participant and the tasks to be done while being scalable at the same time. Here we can see skills as a tree-based taxonomy. So what we see here is which is a parent-child relationship. For example, anybody who can write in English can also read in English. Similarly, those who know the concept of threads in Java 1.8 also know core Java and hence know programming. Considering the problem in this paper, the authors make a few assumptions. It is assumed that the tasks that are listed can be solved with a single skill, and at the same time, safely assumed that the skills given are correct and already assessed. There are also other assumptions with respect to the participants, wherein the participants accept the task that is assigned to them and that the same task isn't mapped to multiple participants. The study ignores spammers. So, how are the tasks assigned? A task assignment is the mapping of the task T in a set of tasks T to a participant P in the set of participants P. The platform takes the task with required skills and assigns it to the participant with the exact skill that's present in the skill taxonomy shown before. If a skill is required which isn't available in the tree, we settle for a more generic participant, but this would mean that the quality of the task could reduce. In such situations, the concept of skill distance is used between required and available skills. The normalized skill distance between two skills is the distance between the two skills that is determined by the depth of the lowest common ancestor or LCA of the two nodes in the tree. If the root is the LCA of two nodes, the distance is 1. When calculating the distance between the task and the participant, the distance is 0 if we have a participant who has the required skill or more specialized skill. Otherwise, it depends on the distance between the task skill and best available participant skill. The final quality of the assignment is the sum of the distance between each task and participant. Task assignment problems are addressed by various algorithms. To demonstrate their model, the authors have proposed two heuristics, used two baseline algorithms, and one optimal solution. The first step of the match participants first algorithm is to assign most specialized tasks to participants. By doing this, the participants with diverse skills for other tasks are being saved. Then, by reverse sorting the task skills, the most specific skills of each branch in the skill taxonomy are obtained. And by doing this, the least diverse participants are obtained first, and the task is assigned to the first available participant starting from the distance 0 to dmax. The profile hash algorithm uses indexes and organizes the skills of the participants. In the process, it picks up tasks that are more difficult to assign and assigns them first. Then, for each task, the algorithm looks for participants who have the exact skills first. And when such a participant isn't available, it looks for participants with more specialized skills and starts from the least specialized. At this stage, if no participant is available, the condition for the required skill for the task is progressively relaxed and the participant is assigned. The baseline algorithms used are first, random algorithm. This algorithm assigns tasks to participants randomly. It shuffles the task's IDs and the participants' IDs and then makes a complete one-to-one assignment between them. Second, exact, then random algorithm. This algorithm first matches task skill with participant that has exact same skill and assigns the remaining tasks and participants randomly. Here, the skills are recognized, but the advantage of taxonomy structure is not taken. It can be interpreted as a keyword-based matching of participant skills with the tasks. Optimal algorithms. Hungarian match is an optimal algorithm. It is a combinatorial optimization algorithm often used to find perfect matchings to obtain assignments with minimum normalized cumulative distance.
For the experimental settings, The algorithms that were used for synthetic data setting are random, exact then random, match participant first, profile hash, Hungarian match. The algorithms that were used for real data settings are random, exact then random, and profile hash. In the synthetic data setting, each task is associated with only one skill and is generated as a random path on the taxonomy tree. Here, the authors propose a budget method to find a specific skill under the assumption that a participant can have several skills, but according to a budget. The experiment was carried out in the following manner. First, a number of tasks were generated with the above mentioned method and an equal number of participants were generated. The authors used both the generated tasks and participants as an input to the baseline and heuristic algorithms. This procedure was repeated 10 times so that each point in each figure represents the aggregated result of 10 repetitions of random data with the same characteristics. The approach was assessed on 6 different figures, supporting its scalability and improved the quality, time, cost, and effectiveness. In the first case, normalized cumulative distance related to the assignment with respect to the number of participants is plotted. The second figure shows the time in milliseconds needed for each algorithm to make a complete assignment of all participants to all the tasks. The figure on the left shows the time needed for a complete mapping of 10,000 to 500,000 participants and tasks. And in the figure on the right, we see how the budget of skills of the participants affects the assignment in finding better mappings. The figure on the left shows how depth of taxonomy affects the quality of assignment. And the figure on the right shows the distribution of assignment distances between the algorithms. The following observations were made on the synthetic dataset. The heuristics provided by the authors give better results than random or exact than random. Profile hash is an excellent candidate for a scalable high quality mapping algorithm. For this experiment, two baseline algorithms and the profile hash heuristic were used to obtain the results. The experiment was done using three types of audience: laboratory participants who were well versed with the topics they were experimented on, such as computer science, and included graduate students, researchers, and engineers familiar with computer science, crowdflower participants, and finally, mixed crowd. The first figure on the left shows ratio of correctly answered questions with respect to the three different crowds. The next figure on the right also shows the ratio of correctly answered questions with respect to different crowds, but this time the questions were annotated two levels higher in the taxonomy. The following observations were made from the real data setting. Proposed profile hash method outperforms baselines. How different crowds affect percentage of correct answers. Supports intuition that with crowdsourcing, the good use of greater number of participants improve the result. Simple model of vector of skills can significantly improve expected results. The proposed model supports search for more specialized participants. Even when there was a lack of information on tasks, the algorithm performed a better mapping and provided better results. The paper also discusses some of the related work such as taxonomies of skills versus keywords. As evident from the table, keyword-based skill management is useful in terms of flexibility and dynamicity, while taxonomy-based skill management is efficient in terms of precision, recall, reasoning, and structured assessment. To conclude, in this paper, the authors have done the following: demonstrated taxonomy-based skill modeling for crowdsourcing, reasoning about skills and participant substitution that is useful in optimizing task assignment quality, proposed heuristics for task assignment to participants, evaluated performances in terms of quality and scalability through extensive experimentation.